All right, so we're going to continue talking about logarithms with base e, which is in the natural log. So to solve an exponential equation by using natural logarithms, isolate the variable by first taking the logarithm of both sides of the equation. We can use either base 10, which is the common logarithm, or base e, which is the natural logarithm. These are the ones found in the calculators. But since our equation involves e, it is easier to take to use the natural logarithm. So let the equation that's given to you kind of decide what you're going to be using. So if you see e there, you're going with natural log. All right, so we're going to take the natural log of both sides, and then we're going to kind of convert that using the logarithm of power property. So this was going back to when we were doing those properties. So I have y minus 9 with the natural log. With the e, I don't actually have to put the e there. I was just showing you it didn't disappear, equals the natural log of 9. So now we're going to go here because the natural log with the base of e is actually equal to 1. Okay, so that's why it kind of disappears. I was just showing you instead of just having it gone, you can kind of still see it there. But now it does, go away because we're multiplying by 1. So y minus 9 equals the natural log of 9. I'm going to add 9 to both sides. So y equals the natural log of 9 plus 9. Now I can use the calculator. Just filling in all this stuff again. That's silly. There we go. There's the calculator. So the natural log of 9 plus 9, and I can hit equals, and it will give me my answer. So it wants me to round to the nearest hundredth, so make sure you're paying attention to the rounding instructions. 11.19 would actually give you the wrong answer. It's going to be 11.20 because that 7 is going to round the 9 up, which is going to round the 1 up, right? So make sure you're paying attention to the rounding rules. It did say no intermediate computations within the problem, so that means you don't want to be taking the logarithm of anything until you get to the end of the problem. You want to wait off on any of those computations. Because if you round and then tried to add 9, if you did the log of 9 and then added 9 after rounding, you would get the wrong answer. So just be careful about that with the rounding. So we're going to try that one more time. So we have to solve a multi-step equation involving natural logs, first isolate the logarithm, then write this equation in exponential form and solve for x. So we're going to isolate the logarithm. So I don't want this 2 in the front, so I'm dividing by 2 on both sides. So I end up with the natural log of x plus 2 equals 6. And now I'm going to use exponential form to show, remember this is natural log, so it means it has a base of e. In logarithm form, this 3 was my exponent, and my answer to my exponential form is the base for what I'm taking the log of. So x plus 2. All right, so now I'm going to subtract 2 from both sides. And I'm going to have e to the third power minus 2, and I'm going to use my calculator again here. So I have e to the third power minus 2. You just type this one in and hit equals. There we go. We get 18.0855. And it wants us to round to the nearest hundredth. So again, I'd go to this 8, which is going to round up to a 9. So 18.08. So if you put 18.1, you'd get it wrong. If you put 18, you'd get it wrong. 18.085, you'd get it wrong. Make sure you're paying attention to the rounding instructions. So I've seen students get to this point and then just simply not pay attention to what they were supposed to be rounding to. So 18.09 would be the correct answer. All right, so that is using logarithms and natural logs to solve multi-step equations. I will hope that helped, and I will see you in the next video.